I'd like to welcome here on stage Martin Baier from Lanxess and Laura Rolfsen from Microsoft Deutschland for the presentation on Lanxess' way to data-driven decisions using Microsoft technology. Martin has been a research assistant at the RWTH Aachen University, and since 2019, he's been at Lanxess leading the machine learning platform for the development of chemical products, and since 2021, he's been a senior data scientist at Lanxess. Laura graduated at Maastricht University with a Master of Science with a specialization in business intelligence and data management. She has been with Microsoft for 5 years with customers in the chemical industry with a focus on realizing their data use cases to drive value for these companies. Thank you very much, and the stage is yours.
Thank you, Lucas.
Yeah, good morning, everybody. Also, a warm welcome from me. As mentioned, I'm Martin, Senior Data Scientist and Platform Architect, and we're going to present Lanxess' way to data-driven decisions. And Laura is going to start.
Great. Good morning, everybody. I'm Laura. I'm the account executive for Lanxess from Microsoft. Happy to present today to you the Lanxess way to data-driven decisions. We have prepared 3 parts for you. So I will talk about the approach that we used at Lanxess. Then Martin is going to take over and talk about the implementation that was done with Lanxess, Mobilab, and Microsoft together. And then we'll also have some learnings for you to round it up and continue our discussion. So why do we have the first slide on here with all the different bubbles and different departments? I think it's one of the key parts that we want to bring across is that the data platform is supposed to also connect the different departments and solve even bigger business problems that you have that are overarching. And before we really dive deep into the approach, I want to ask you what question comes up when you see this picture. I think this is something we have all seen on the news, the Suez Canal. And it's not an example we have used at Lanxess, but I think it really explains why there's a great need for a data platform. So sales is thinking, oh my God, is there something on there that's supposed to be for my customer? Production is thinking, is there something I need for my production? Logistic is thinking, oh my God, what do I do now? And the CIO is obviously asking, so what kind of impact does this have on my business? And this leads me to the approach that was used at Lanxess. And we always started with a question, what is the business need? So they ask questions like, how can we improve customer service? How can we optimize logistics? And really connect it with the business there to move forward. Then the second question was always, what kind of data can be used? So the identification of the data that's necessary, internal or external data, and then obviously combining it with the data owner knowledge. And the third part was, how do you transform the initial data that you now have? And there the team from Martin comes into play with data engineering, data scientists, some AI tooling, and really helping the business there to gain their insights. And then last but not least, how do you display this data? And there was a strong connection between the process owner at Lanxess and always someone from technical side to really bring the value to the business department and actually help them solve their problem. And for me, I think the key success factor that we saw at Lanxess was that there was a regular exchange between business and the data platform people to see what is really possible, what is not possible. And there was a central budget. So meaning there were no discussions and at the beginning of a meeting or a call, who's going to have the budget, who's going to pay for this. So it was also a good way to get into contact with business, make them curious and have them engage with the data platform team. And in the end, you can see it down on the slide. This platform should provide the guardrails for handling data as a product. So now I will hand over to Martin, who's going to talk about the implementations. And we focused on these 5 aspects for building this common data platform. So analytics, apps, data sets, security, and lineage. And with that, Martin is going to take over.
Yeah, thank you. So I'm going to start to talk about the data sets part. And if we think about how the data landscape at Lanxess looks like, then we have a lot of different data sources, data here, data there, and they exist by themselves as silos. And bringing this data together is one of the key learnings that we had, because if we want to bring additional benefits or go for data decisions, then we need to combine the data, no matter where it lives as the true source. So what we did is we brought 40 plus different data sources together and brought the data into a central data lake to make them discoverable, to have access control on top of them, and store some metadata additionally. Then, as soon as it is in the data lake, we categorize the data as either being binary or being tabular. Examples for binary data could be contracts like PDFs, photos of quality measurements, for example, which obviously contains lots of valuable information that we need and that we need to deal with. And tabular data, I mean, that is obvious. Everything that can be displayed as a table, we consider as tabular. And for these tabular data sets, we went one step ahead and said, okay, this data needs to be accessible. And we implemented an automatic SQL interface for every tabular data set using Azure Synapse SQL and using external tables so that we don't have double storage. And that means that we have a standardized access and a standardized connection way to data and in such a way then we can connect any kind of known visualization tools that support SQL. And I guess all of you know that most of the tools support SQL for input data sources. We heavily use Power BI, but also custom Python apps, and I'm going to talk about in a second about that. But that kind of approach brought one really requirement to us, which is data access needs to happen always on user's identity, meaning that there's no intermediate computer identity or whatsoever, but everything happens on user's identity. And with that, the whole access procedure is also safe, and people can freely, without support from us, or if they need support from us, connect to the data and display them in any tool they like that supports SQL. In the end, that brings us a high flexibility for the end users, using state-of-the-art technology. About the visualizations, we currently have two main flows. On the one hand side, we have the Power Universe / M365 universe, oftentimes using Power BI and Excel. And we consider that, let's say, as no-code, low-code approach, where we have quick iterations, where people have a lot of support. Also online, there are lots of tutorials where people can help out. Because as a central data team, you cannot solve for a big company with multiple thousand employees the issue that everybody needs help. So establishing connections to standard tools, we thought was a good idea. And that also means that we have a decentralized approach, that people can actually go ahead and help themselves to get towards data-driven decisions. On the other hand, we all know with no code, with low code, not everything is possible. So we need to be able to customize something. And for that, we decided to go for some specific Python applications, such that people can customize, develop apps, or data scientists, data engineers, software engineers, whatever is needed. And also there from the platform team, we said we need to support that, to have some standards, like we need a standardized authentication, standardized design, how to connect the data. That is all standardized. We offer Python libraries in this case. And with that, we have all sorts of, from self-service to fully customization supported, including standard software development flows like CI/CD. This is all because we believe that decision makers, in the end, they don't care which tool we use, but they need highly dynamic and always up-to-date and obviously meaningful visualizations. We have too much data and nobody can just look at everything. So having a small database is having a small visualization that combines everything, aggregates everything, is the key. How does the data actually get then in the end to such a dashboard? And for that, we have developed a very broad analysis framework. And one of the first things that we wanted to have is everything needs to be versioned. We are fully Git-based, meaning that everything that we do is based on commits. And I guess all of you know what Git is, and you can see here on the upper part of the figure on the right-hand side, which is actually a real figure from our production system. you can see that we are on the main branch and on the latest commit on the top. But there are also possibilities to change branches, commits, and so on. You can also see that we wanted analysis to be modular. And what you see here a bit highlighted is a central step and a lot of inputs and a single output, and a couple of more steps that are, let's say, a bit more in the background. And this is automatically detected from the code that we have and then brought into that visualization. You can run individual steps, you can run the whole pipeline, you can trigger the whole thing, meaning scheduling and so on. We are also thinking that most of the developers like to use their own local tools, meaning we support fully local development. People can run their code locally. Obviously, this has some limitations on your local memory, but especially for debugging, this is very helpful if you can just download it and run it locally, and then have a smooth and easy deployment flow to bring your local things to production, and that is also standardized on the platform. In the end, we are a code-first platform, but we have also transformation modules that are low-code, no-code, where I can change a visualization or where I can add a new visualization, where I can join new data sets, where I can filter, and so on, just to give you some examples. This kind of structure, this kind of modular structure actually allows us to go for something that we call a lineage, and we use it a lot for governance, but also for debugging. Here you can see a figure where you can see the flow, how data flows from left to right, and how the different data sets are connected to each other. And in color code, you can actually see the sizes of the data sets. They are from small to big, and that also gives you some insights. Okay, there's maybe some aggregation happening, there's some joining happening, and so on. But this is only one view that we have. We have, for example, also access control as a view. So you can say, okay, I want to have the access control view of the lineage and then select a specific user or a user group. And then I can see this user has read access, this user has no access on this specific data set, all color coded. And this is very beneficial for governance, for audits, for example. And last but not least, of course, last update status, last update times, they help a lot in debugging and to find issues in such a big pipeline. Actually, you see here two pipelines, one at the top and one more at the lower part. And if you see this part has failed, then I can know, okay, the rest is already broken, and I have already a starting point from where I can go forth and back. Architecture-wise, this is a high-level architecture that we use. We start with the sources. They obviously don't belong to the platform itself, but we thought we put them here because we integrate to basically any data source that we at least have at Lanxess. And this integration happens via Azure Data Factory in our case. And as I mentioned before, we store the data in the Data Lake Gen 2. GitLab is our tool of choice for storing the repositories, both for analysis and also custom Python applications. And we are heavily using Azure Synapse for both running jobs, for example, on Spark, but also, as mentioned before, to implement the SQL interface. The application layer is based on Kubernetes and Python on one hand side and Power BI on the other hand. The platform is also Kubernetes-based. Lineage is using Cosmos DB as a backend storage, and everything that comes with security, authorization, authentication, and so on is based on what the Azure Active Directory offers to us. And with that, I hand back to Laura.
Yeah, thank you, Martin. So what I want to point out on this slide, and I mentioned it before, is that this was developed by Lanxess, Mobilab, who's a data partner based in Cologne, and Microsoft together. And one of the highlights we see here, and definitely important since the data world is changing very fast, that we choose this modular approach here, so you are able to exchange some of the layers that you see here. So we always discuss what are the newest technologies, there's something we should change, and that obviously also reduces the login for Lanxess in this case. Before coming to the questions, we would like to share some of the main learnings with you. So as we mentioned before, we see that you foster a collaborative approach is definitely one of the key factors or one of the key learnings that made this project successful. So having a good interaction between business and the data platform team, use state-of-the-art technology that has increased the acceptance with the business users and has also been able to get good help from different technology companies. Then constantly question what you do. So we had regular discussions. Are we on the right track? Do we need to change something about the path that we're going? And we keep on doing that, not only from an IT perspective, but also including the business in these conversations. And then last but not least, we reflected on this and think that having a reliable platform that should serve as the great rails for business are an important step so that people in business know who to approach, that there is something that they don't need to build something themselves or, build it up in every department. And in the end, you have no overview of this. So these are our learnings. And with that, we would like to open up the round for questions.
Yeah, I agree. We have actually both. We have a data team that does, let's say, legal reporting that is needed. We have also a data science analytics team that helps to also define new KPIs to help out in, let's say, emergency cases or finding new business cases, finding new operational models. But that would not work when you don't have the data owners with you on board. And most of the data owners that we know actually have some very good understanding on what they actually would like to see in the end. And if we work in a combined way, like cleaning the data by a central team and then giving it back to them, helping them to visualize whatever they want, we come to some kind of middle ground, let's say. Of course, the quality is always an issue, and I can really confirm that we are no exception there. But still, I think, knowing what has to be the quality can only come again from the data owner. So close collaboration, I think, is the key to that, what we need. And we also see that more and more people that start actually at Lanxess are familiar with some kind of data analytics, either Python or Power BI or both or something else like R. And with that can also help a lot themselves or the whole department. All good. So yes, I can confirm that is something that we developed ourselves. First, we started actually implementing that before Purview was on the market. So that maybe answers your Purview question. And on top, we also integrate very closely with what we have as analysis framework based on Python. And that allows us also to flexibly extend it to our needs. In the beginning, we actually started only with access control. And then we thought for debugging purposes, we need this and we need that. So we develop in a close collaboration with what is actually needed by the business or by the data management team. So that's why we went for a custom implementation.
Yeah, Thank you very much, Martin and Laura, for the wonderful presentation. I've seen a lot of people taking pictures, so hopefully you're around, willing to answer a few more questions. Thank you very much. Before coming to our next presentation, I'd like to invite... Oh, yeah. That's a good cue. Thank you very much.